Hi, welcome back. In this video, I'm going to show you an easy way how to determine the safe maximum velocity for an ammunition that you have never loaded before. To do that, I'm going to use Excel and a few functions. First of all, before we can do any calculation, of course, we need data. Where can we get the data from? Of course, from the manufacturer's site. And to make this example more realistic, I happened to choose a nowadays popular cartridge, powder, and bullet combo. So I happened to choose 6.5 Creedmoor, Winchester Stubble 6.5 gunpowder, and Hornady ELDX bullet in 143 grain weight. So the first source we can use to get data is the hodgedonreloading.com website. Of course, we are looking at rifles. Then next we select the caliber, which is 6.5 Creedmoor. Here go. Next is we select 143 grain for the bullet. And I'm not going to filter any further because I'm not interested in saying one particular powder. What I'm interested in saying is all the data that is relevant to 6.5 Creedmoor and bullets in 143 grains. So just hit get load data, and there you go. So that's quite some data. Here are the powders, the grains, velocities, pressure, etc., etc. Yeah, don't worry. We only need two columns from this data set, and they both belong to maximum load. We need the data for charge in grains and velocity. I've already copied these data, pasted them into an Excel spreadsheet. As you can see here, source is Hodgdon. These are the powders. These are the charges, and these are the velocity numbers. That's not all the data we can get. We can grab some data from Hornady too, as they are the bullet manufacturer. So if you go to Hornady website, it will tell you that Hornady moved all the reloading data from their website to the mobile application, Hornady Reloading app, which you can easily download from either from the App Store or from the Google Play Store. I already copied the data and pasted them to the same Excel sheet, so we have everything that we need in one place. Here you can see source is Hornady, and we have the gunpowders listed here along with the charges and velocity numbers. So we have all the data we need, and we can get started. We're going to do all the calculations in column F. In column H, I added some some brief explanation to show what actually is being calculated in column F. And column I put the exact formula. So if you want to do your own calculation, you can choose these functions. Step one is we need to calculate the mean or the average value, the average velocity of this data set. That happens to be 2,752 feet per second. That's easy. Next step is we need to calculate ES. ES stands for extreme spread, and that, as column H says, it's basically the difference between the highest and the lowest velocity. It's in our case, it's going to be 97. Next, we need to calculate SD, which stands for standard deviation. Standard deviation is basically data dispersion in relation to the mean value, to our average value. You can use the built-in stdev function, and that's going to give us 34 as our SD value. And let's stop here for a second before we continue with our calculations. and have a look at the graph at the bottom right corner. So this graph has been grabbed from gunsandammo.com, and this is a brilliant graphical representation of standard deviation bell curve. What does this show us? As you can see, this is the curve. This is our SD value curve. Right in the middle, you can see this zero line. This is the mean line, the mean value, or in our case, it's our average value. And as you can see, this curve is very symmetric. So why does it? Why is that important for us? It's important because, as you can see, if our SD is 34, that means if we take the mean value, we can be assured that 17 FPS are on the left from the mean and 17 are to the right from the mean. The next calculation we're going to be doing is we calculate the ideal maximum velocity. And we do that by dividing our SD value by 2, because it's 17 to the left, 17 to the right, so we only want to use 1/2. And we add that to our average value. To be more precise, we're going to be adding 17 to 2,752. And that will give us 2,769. Next step, final step that we do with the Hodgdon dataset is we want to calculate the coefficient variance or CV percentage number. And we do that by dividing the SD value with the mean value, with the average value, and multiply it by 100 to arrive at a percentage. In our case, that's going to be 1.24%. And a little help here with the colors. As you can see, if your number is less than 10%, then your result is excellent. Between 10 and 20%, the result is good. It's very good. It's okay. Between 20 and 30%, the result is acceptable. You can still use it. It's not great, but it's still usable. But if your result is greater or 30% or greater, then something went sideways, something is wrong. You cannot safely use that value. So what can go wrong? Number one issue used to be you made a mistake in your calculations. So make sure you always double check or even triple check your calculation and make sure they are correct. Possible issue number two is when you typed data into the data set or pasted data from a website, for example, you made a mistake or some invalid data was entered or typed or pasted. Make sure all the data is valid here. Possible issue number three is you have some very low or extreme high velocities. Like as you can see here, all these velocities are in the 2700 range. Yeah, one is just below 2700, and this one here is quite like 2791. It's a bit above 2700, but it's still we can say they are all in the 2700 range. If I had data like 2400 or any value say above 3000, that would be extreme on any or both ends. In that case, what I would do is I would just simply ignore the lowest and highest numbers and work only with the numbers in between. You don't necessarily need to delete them from the Excel spreadsheet, but at least you need to modify your average calculation formula to make sure that those values are ignored. And then for all the subsequent calculations, you will use the correct average number. Okay, now that with that being said, all that's left to do is we need to repeat the same calculation, but now based on the Hornady dataset. You can see there is nothing to ignore here. All the values are in the 2700, let's say between 2600 and 2800. So that's again nothing to ignore. You can use all these values in your calculations. When we calculate the average, it happens to be 2722. Our ES is 250, and our SD value is going to be 69. It's a little bit higher than what we saw with the Hodgdon data, but it's still close. So we are on the right track. Next, we calculate the ideal maximum velocity based on the Hornady dataset by adding half of the SD to the average value, and that gives us 2,757, which is quite close to 2,769, what we saw based on the Hodgdon dataset. If we calculate our CV value, the coefficient variance percentage, that gives us 2.53%, which is brilliant. It's still under 10%. It's an excellent value. We are good. We can use them. And we are on the right track. And there is only one thing left to do, is basically we have two average values here and here. We compute one more average value, the average of these two numbers, and that happens to be 2,737 feet per second. Just to be on the safe side, you always want to round it down. You can use either the built-in floor function in Excel, or you can do the rounding manually, just like I did. I round it down to 2700, and that says 2700 FPS is very likely achievable from any and every gun chambered in 6.5 Creedmoor caliber, shooting 143 grain bullets. Make sure when you do your load, you always start from the minimum load and work up your load in 0.2 or maybe 0.3 grain steps, and you watch out for high pressure signs. But there is a very, very good chance that 2700 FPS is achievable from your gun. Right, guys, thank you for watching the video. If you liked it, please hit the like button, subscribe to my channel, and I hope to see you soon again. Bye.